Rewriting R code that is already being used all over the place is honestly one of the most stressful things you can do as a data scientist. Whenever you touch an already existing function just to add another functionality, you risk breaking other parts of your code. And the reason why so many of us R users end up in this stressful situation is because we've never had training, like formal training, in code design patterns. And one code pattern that makes the situation much better is generic functions. The idea of generic functions is pretty simple. You write one function, and depending on what you throw at that function, the function will behave differently. The cool part of this is that you don't even have to touch the function for all the other cases you've already established and for which you already know that the function works. And this makes it super easy to extend your code without breaking things that already work. So in today's video, I'll show you exactly how that works, so let's check that out. Before we dive into the generic function stuff, let's look at a hypothetical scenario. Imagine you want to write one function that can read from different data sources. You want to have this one function that can read from a CSV file or from a database or from some web API. Basically, one function, different interfaces. And to make this scenario less hypothetical, let's actually mock up some code. So for now, let's imagine we have some fake data. It's just a table with fake data inside of it. Nothing too fancy, but this will just serve as a nice example here. And then you want to have one function, let's call it ingest data. It is a function that can take in a different data source. And what in a normal scenario without these generic functions, what you might end up doing is to write a bunch of if-else conditions. So what you do is if the source is a CSV, then here I'm just throwing info, I'm reading a CSV and then returning this fake data. Or in a different scenario, you want to repeat the same thing for a database. Here again, I'm just throwing in a message that says here is where my usual code for reading a database would be, and then it returns some data later on. And then there's another example for the different scenario where we want to read from an API. Again, this message here is a placeholder for the bunch of code we need to handle for this particular data source. So you can see this one function becoming really long and really convoluted as we add more data sources to it, especially because for each of those data sources, there will be more code involved than just saying I'm reading stuff. And more depressingly, in a real scenario, each of those subparts of the function, they would need different arguments. To read a CSV, I need to know the location of the CSV. To read a database, I need to get the connection details to that database and the table that I want to read from inside of it. Probably there might be a query involved that I need to throw to this function. And for the API, there's even different kinds of arguments that you will need here. So what you then end up doing is to throw in way more arguments into your function, and this makes everything very brittle. The moment you want to add another data source, things might get out of hand and this function just becomes even huger and even less maintainable. So now that we have set up this hypothetical example, even with some mock code, let's do the exact same scenario, but with these generic functions. What that involves will be S7 classes. Sounds complicated, I know, but in fact it is. Once you've seen it once or twice, it's actually pretty easy. With S7, what you end up doing is to first load the package. That's pretty easy. And then you create classes using that package. And there's the new class function for that. So you define a data source using the new class function saying this data source class is called data source. Kind of confusing that you always have this object, that it might feel weird that you always have a variable name and then have to reuse the exact same thing inside of the function, but that's just how classes are defined. And now below this data source umbrella, you can have different data source types. For example, we can create one for the CSV file. So we create a CSV source. It's once again a new class. We call it CSV source, and it is a child of this data source. So the data source is the parent object. And then we can have a bunch of properties associated with a CSV file. This is where we're starting to get into the territory where we remember, oh yeah, right, each data source, it needs different arguments, it needs different things to be actually a valid source of that type. This is what we can bundle into these S7 objects. It comes with an overhead of having to specify this stuff now, but it has some nice payoffs later on. So for a CSV file, really all we have is a path, which is just a character that you specify here. So basically think of this as a blueprint for a CSV source. And then we can do the same thing for different kind of sources. For example, for the database source, we can create a class of that name. We can once again say it's a child of the exact same data source object. And then we have a bunch of properties that are necessary for loading data from a database. So in this scenario, it might be a database connection. We call it con. And here to get the exact specification like we had before, we can just say this is a DBI connection from the DBI package. And then for the query, it's just once again a character vector. And then rinse and repeat. You do the exact same thing for the API, defining an API source, saying it's a child of data source, and then the properties here that are needed are a URL, the source that we connect to, and possibly a token. This token is used to authenticate with the web API. So now what we can do with these different objects is to create instances of it. So we can say we want to have a CSV source that is a CSV source that is located at the following path. Basically, we just fill the properties that we have defined are necessary. Same thing can be done with the database source. We just call this database source function that we have just created using this new class. And then we want to have as a connection to an in-memory SQLite database. And our query that we're going to run will be this query. And then for the API source, we can do the exact same thing, specifying that our fake API is located at that URL. And we need the following token that we get from an environment variable. So now if I execute all of this, you'll see that CSV source is now a CSV source object with the path I've specified. Same thing for DB source. It is a connection that has other attributes like the database name. And the API source is an API source object that has URL and token associated with it. Here the token is actually empty because this environment variable doesn't exist. Okay, so now I can hear you say, okay, that's all nice and dandy, but I can't see how this overhead of creating and formalizing the different sources actually helps with anything. And I understand the impatience, so let's resolve it. Let's actually throw in a generic function now that can deal with these kind of different data sources. What we can do now is to create an ingest function, but this time we don't use the typical function keyword to create it. Instead, we use the new generic function from the S7 package to create a generic function. The name of that function will be ingest, just like the variable name that we have used here. And here we say the argument will be source. Now what we can do is to use the method function from the S7 package to actually implement a method for this ingest generic that we've just created for a particular data source. In our case, we can start with the CSV source. And the idea now to implement this method is to assign a function to this method. And here we have used a source as the argument for this thing that we stick into this generic function. And the reason why we did that is because we specified ingest, the generic itself will always get a source argument. So there it is. That's what we can use. And now what we can do inside of this function is to specify the same thing we wanted to do early on, like throwing some code to says we're reading a CSV and then returning the fake data. So let's do that. Let's throw in the code from before. But now we can also make our information more valuable by saying, okay, with this source, it will be a CSV source. We already know that this object has the property path, like we have also seen here. We can access these things as part of the method implementation by using these @ signs. So if we do source, which is then the CSV source, @ path, we will get exactly what we have sticked into it. So let's use this in here. We can say let's do source @ path, and then for nicer formatting we can actually put this into a path class, and then we can return the fake data at the end of this function. So now if I were to take my CSV source and pass it to the ingest function. Then we can execute this thing. You already see that here it is saying reading from this path. So this code here, it works, and it also returns the tibble. The reason it just didn't show the tibble before was because I disabled this when I sourced the whole script. But here, if I only source this line, you see that it returns the data and it does all the other stuff of the code here. So now what happens if we try to use db source instead? Let's take the db source function and pass this to ingest. Then you see that, okay, we can't find a method for ingest db source, meaning we haven't actually defined a method for the different type of source. So what we can do is we can take this template here and then use the actual db source as an input. And then for these scenarios, we want to do other code and at the end return our fake data. Remember how our connection inside of the db source object also had these @signs using db name? That's something we can also then access, because we now know that when we stick a db source object into the ingest function, it has access to all the properties we have defined. And this connection, dbi connection thing, it has db name associated with it. So once again, we can throw in a code from the CLI package to have some nice output in the console. And there we put in stuff like saying using db connection with the value source at connection at db name. That's exactly what we have here. There is the at connection, there is the at db name. And then we could also show the query that is part of the object definition here. So now if we execute this part here, our method is registered for the ingest function. And now as I execute this, we see that, hooray, we get our fake data again. And we see that we have executed this messaging code that we have as part of our method. And then finally, I think you get the idea. For the API, we can do the exact same thing. We can create a method so that the ingest generic knows how to handle API sources. It can, as part of its method code, use attributes from that object type, and then we can pass the API source object safely to the ingest function and it will do its thing. Here you can see how with this generic pattern, you can easily extend your code to do other things by just adding another method definition for a different kind of objects to a generic function. If this still feels a little bit fuzzy to you, let's look at another example. Let's say that we want to have a function that can summarize different kind of machine learning objects for us. So let's load the S7 package and then let's create these S7 classes for different kind of models. For example, for a linear model, we might define things like the coefficients or the R² value. For the Bayes model, we define things like a posterior property or like a convergence Boolean. For the survival model, we define things like hazard ratio or CI. I'm just making things up here just to set up the thing I'm trying to show you here. So basically for different kind of models, we have different kind of S7 objects. And then we can use them through a common interface that is a generic function. Let's call it model summarize. It will be called model_summarize and it will get a model as an argument. So what we can then do is to define specific implementations of that generic functions for all three of those models, just like we have done with this data ingestion example from just now. So let's create one method. It will be the method that defines model summarize for linear model, just the function that takes model as an argument. And then here, once again, I'm just printing stuff. And then we do the same thing for the Bayes model and the same thing for the survival model. Just printing stuff, nothing too fancy. But the cool thing is that we can always use the properties that are associated with a model. So we can use coefs, R², posterior, and so on inside of the respective method. And once we have that, we can create actual model summaries. So let's create a linear model, a Bayes model, and a survival model. These are just outputs of some calculations. Imagine that your actual machine learning model will return a linear model with all the summary statistics inside of it. That's the output, and then we can pass all of them to model summarize and will just work even though the output is completely different. Let me execute this stuff and you see here that this is the output for all of these things. Maybe I should execute them one by one. So this is the output for linear model, this is the one for Bayes model, and this is the one for our survival model. Cool. So I hope with this kind of quick but similar example, you were able to see the pattern more clearly of how this generic function works by defining specific methods for different kind of objects. And if you're anything like me, you might still be a little bit on the fence about why is this actually helpful. You still have to define a new function for a different kind of object, and you have to define a different kind of object if you want to have different behavior. Those are very valid points, and I have been wondering about the same thing initially too. But the really cool advantage of this thing here is that you don't have to touch any existing code to extend what your code as a whole can do. To make my point clear, let's look at another example of this model thing, but implemented without generic functions. So what we could do is to write a function called model summarize2, and it will fetch the model name from the model that we stick into this. And then we do this mapping ourselves, saying, okay, for each case, we have one function, model summarize linear, model summarize Bayes, model summarize surf. And then we just figure out, depending on what we stick into this function, what of the other functions needs to be executed. And then we do that. That's basically what this code does. And then for each of those sub-functions, we have one implementation. Sure, here it is. And then at the bottom, we have all our linear models from before executed using this other function. And now if we execute this, we see that, okay, cool, we get the exact same output. We didn't have to use any generics, and we didn't have to define a method for a generic function. But what we still used here in this example, just to be clear, we still used S7 classes to bundle together different kind of things. And even in this scenario, we see how useful this is, because in our wrapper function, we can get the class of that model object immediately, and then we can differentiate what kind of other function needs to be called later on. So even if you don't want to use generics, S7 classes are great, because you can then bundle things together into one object, and in the specific implementations, you just access the properties using this add sign like we've seen before. But still, this implementation has a crucial drawback. Imagine I were to create another class for a different model. Let's call it random forest model. So in this case, just another class that we call RF model. And then we have different kind of properties like importance, OOB arrows, number of trees. Imagine we have this additional class. And now we want to create a specific instance of this class, just filling this with numbers here. Oh, I actually have to execute this other part as well. Otherwise I will get an error. So now we have this new model. But if I were to stick this into my new function that I've just created, the one where we don't use generic functions, we'll see that, okay, this throws an error unsupported model, because I've actually thrown in this error message in here. So now if I want to have my function work for this new type of model, I have to extend the list of things here. And this means that I need to touch this function again in order to extend my code. That's different than with generic function. With generic function, I could just assign a new method for this generic function. You see, if I were in a different file additionally to the class I'm just creating, if I were to also define a method for this, then I could just call model summarize like I did before. Let me execute this stuff. And you'd see that this works out of the box, because I've registered a new function to this generic. So while you will still have to write code that can treat this new object type, you don't have to go into existing code to ingest all of that stuff into different parts of your code, because this generic method dispatch will handle all of that for you. Cool. So with that, we have taken a glimpse into S7 objects and their generic methods. Hope you enjoyed this video. Let me know in the comments if you did. Also make sure to mention things I should talk about more in more details. And if you want to learn more about S7 classes or want to get a deeper introduction into them, make sure to check out this video. And now with all of that said, I say thank you for watching, and I'll see you next time.